Hello everyone, and welcome to this second video on IIS 7.5 architecture and components. My name is Cociuba and I'm an escalation engineer with Microsoft on the Asp Net team. If you watch this video, you might also want to watch the first video of this series, which is in the related links and which presents an overall view of the components and services of the IIS 7.5 web server and the way they interact with one another. In this video, I want to discuss in more detail the components that are inside the worker process. That is the W3WP exe process that runs the code of applications that are hosted in a given IIS application pool. I also want to look at the difference between the two modes of application pool execution exposed by the IIS 7.5 server. Classic mode pipeline versus integrated mode pipeline. So with that, let's get started and let's just jump right into a Windows 2008 IIS 7.5 server in the IIS Management Console. And as you can see, I have several application pools present, and you will notice that I have a column here called Managed Pipeline Mode with two values, either classic or integrated. Now we can change the way an application pool executes by bringing up the basic settings either from the context menu or from the actions menu on the right, and choosing classic mode over integrated mode or vice versa. But before we change the execution mode of an application pool, I want to go back to my slide deck and I want to actually show you what is inside a WPW3 process executing in classic mode pipeline. This is the same execution mode as you would get in the IIS 6 web server, which runs on Windows 2003. So as we've seen in previous videos, the IIS 7 server comes with both kernel mode and user mode components, and the kernel mode component is the HTTP sys kernel driver, which talks to the TCP/IP sys kernel driver and actually listens for all incoming requests. Now this kernel driver exposes APIs, both managed and unmanaged, to the user mode components, so basically the processes and services that run in user mode. And one of these processes is the W3WP exe process. So let's have a look at what's inside. The first thing we note is that there's a piece of it called the Ias Core. Now this is a piece of code which is unmanaged code, so C++ code, that is written by Microsoft, and that first of all exposes a couple of ISAPI or Internet Services API filter notifications, which are the following: pre-process handler, authorized request, and URL map. Following these, we have a couple of stages to traverse, which are authentication, compression, custom errors, and determining handler. So all of these will be traversed by an incoming request, and you can think of these much like a vehicle assembly line, where you have cars that are stopping at different spots in the assembly line for workers to perform different operations on them. That's exactly how a request is treated in IIS. And finally, we have at the top level what are called the handlers. The handlers are the pieces of code that will actually generate the HTML response. And there are three big categories of handlers that we have in the IIS server. The first one is static file, and this goes back all the way to the beginnings of the internet, because the first thing that we saw on the internet was people publishing text. HTML stands for Hypertext Markup Language. So they were publishing articles. So what we needed to do was we needed a capacity to go read some file from the disk and then send it over the network. And that's exactly what the static file handler does. It just reads files from disk, presumably if they're there, and sends them back to the connecting client. And this can be HTML files, they can be JavaScript files, they can be images, or any other kind of files that you can imagine on disk, and that don't require execution. They just require being read in and sent over the network. As the internet evolved, we also moved to see something called CGI, or Common Gateway Interface, because we needed some way of letting external code execute and actually be able to generate dynamically some sort of HTML response to a request. So the way to do this was to implement an interface to talk to the IIS server, and whenever we determined that the request would go to a CGI handler, what would happen was that an external process outside of the W3WP process would get started up, and when we started it, we actually would pass command line prompt parameters to it, ask it to execute the request, hope it comes back with some sort of an HTML response, and then shut it down. And by the way, this is the way that PHP or Perl used to work in IIS. And finally, the last handler that we have, the last major category of handler that we have, is the ISAPI extension, or the ISAPI handler. This is called Internet Services API extension. Okay, so instead of having an external process launch and then shut down after each request, we said, well, why couldn't we just load up code inside the W3WP exe process and keep it in the process and re-execute that code as many times as needed as we get incoming requests. It's much faster because we don't have the overhead of starting up and shutting down a process when a request comes in. And now, when IIS 6 was designed, the .NET framework was still rather in the early stages, so the only way to integrate ASP.NET into IIS was to write something called an ASP.NET ISAPI, or an ISAPI extension. So if we have an incoming request, the incoming request will be relayed to the worker process via the HTTP/SYS APIs, will traverse all the ISAPI filter notifications, and then we'll go to the determine handler stage. And in the determine handler stage, if we determine that we need to execute, for example, an ASP.NET page, what happens is that we load up ASP.NET ISAPI inside the W3WP exe process. Now, what goes on inside is that we have a sub-assembly line for the ASP.NET part of the request, which goes through a couple of different stages: URL map, begin request, authenticate request, authorize request, resolve cache, handler map, and handler execute. And then we have, exactly as we do for IIS, a bunch of handlers, which are called managed handlers now. And the two most famous ones are the page handler and trace AXD, which is the trace handler which provides debugging information. So the page handler is the piece of code from the .NET framework that will actually take an ASP.NET page, run it, and return an HTML response. So if we select the page handler and then we go ahead and we traverse a couple of more stages, which are release request state, update request cache, and end request, we then relinquish control back to the Ias Core part of the code, which will now go ahead and actually traverse more ISAPI filter notifications on the way out, log session and net session, and then send the response back via the HTTP/SYS APIs to the connecting client. Now, how does this work in knowing if we need to route to an ISAPI extension or the static file or a CGI extension? Basically, there are a bunch of filters down here, among which there's something called an ASP.NET filter, which will say, hey, if this extension ends with a .aspx extension, then please go ahead and route it to the ISAPI extension for ASP.NET. The problem with this scenario is that, for example, if you want to do forms authentication only works for ASP.NET. It doesn't work for any other content. Let me just show you that. If we trace a second request that comes into the worker process, and suppose that this request is for an image file. So therefore, we go ahead and we invoke the static file handler, which will just go read the image out in from disk and then send it back over the network. Now, in this scenario, you do not have any notifications that are sent all the way to ASP.NET ISAPI. So all of the functionality exposed by ASP.NET doesn't even know that a second request came in and was treated by IIS and had no way of actually processing that request. So there are a couple of drawbacks, and this is one of them. The other one is that the Ias Core is monolithic. So for example, in authentication, we can only have the authentication methods that are exposed by IIS, which are basic authentication, digest, Windows integrated, and certificate mapping. So if I want to make my own authentication method, I can't do that because IIS doesn't allow me to replace the code which is in the authentication part over here with my own code. So if I just was to an IIS 6 web server and show you that, In the IIS Manager, if I go to the website properties on the directory security tab, what you can see is that I have an authentication and access control, and I can basically choose between anonymous authentication, integrated, digest, basic, and .NET passport authentication. I cannot choose any other type of authentication, and I cannot add any other type of authentication to my website. So if I want to do Paul's authentication, I can't do that because there's no way of me actually getting inside the Ias Core and replacing code, because that's one piece of code that's delivered by Microsoft. So, and there are a couple of other drawbacks, and basically let's just have a look at them. So the main thing we can say about this architecture is that it's monolithic and that we cannot add or remove features from the server, and authentication is a good example of that. There's also feature duplication between IIS and Asp Net. For example, think of the forms authentication, forms authentication, and think also of error pages. Error pages have to be configured once on the IIS side. If we're hitting the static file handler, the static file handler will actually go ahead and throw up error pages like 404 not found if it doesn't find a file. Now, if we route to the ISAPI extension, ASP.NET will have its own page, its own set of custom error pages, so even its own custom 404 page that it will throw up if it doesn't find the page we are asking it for. So basically, to get a consistent look and feel for an application, we'd have to go into both IIS and ASP.NET to configure custom error pages if we wanted to do that in classic mode pipeline. Now, features are also limited to their position in the pipeline, and think about forms authentication in the way that we could not do forms authentication on the second request just because ASP.NET was never notified about it. And also, we cannot apply, for example, ASP.NET functionality to anything else except ASP.NET content. There was a way around this, which was to actually map every incoming request to the ASP.NET ISAPI, but that's very, very poor performing. So now what I want to do is I want to go into the managed pipeline or the integrated pipeline and show you how it is different from the classic mode pipeline. So again, we have the HTTP/sys kernel driver in the kernel mode and the HTTP/sys APIs in the user mode to be able to talk to the worker process. And now you can imagine that the assembly line, instead of having one assembly line for the IIS request and a sub-assembly line for ASP.NET requests, we merged them all into one. And we said, hey, you need to have a couple of stages which you need to traverse if you are an incoming request. And these stages are begin request, authenticate, authorize, resolve cache, map handler, acquire state, pre-execute handler, execute handler. And then we can remember that basically we had handlers which came from the IIS side, and we had handlers that came from the ASP.NET side. So now we have two different categories of handlers here as well on top, which are the native handlers and the managed handlers. Native handlers, we can still find the static file handler or the ISAPI extension. By the way, CGI is still in there, and there's another one that is called FastCGI, but we can also find the page handler and the traceAXD handler, and we can also write managed handlers of our own if we wanted to, and they're exactly in the same pipeline position as the native handlers. So as a request comes in, it will go ahead and it will traverse all of these stages between the begin request and the execute handler before being mapped to either a native handler or a managed handler. Now, and what's special about this pipeline is that each of these stages is implemented as an event. So basically, you can think about it as a .NET event to which you can subscribe. And basically, there are APIs for each one of these stages which allow you to subscribe to the event which is when the request traverses that particular stage of the pipeline. And the neat thing about it is that you can either subscribe by writing non-managed code or native code, so basically C++ code, or you can write code using managed languages such as C# and .NET. So now I can write my own managed module to actually provide authentication functionality if I'm not happy with the IIS one, and I can just remove the IIS functionality, which is basic authentication, Windows Digest, or certificate mapping, and replace it with forms authentication. After I traverse all these pipeline stages, I will go ahead and I will actually pick a handler, either managed or native, and then I will be able to execute my request, get a response, and then there are more pipeline stages to traverse as I am leaving the managed pipeline. So end, log, update cache, and release state, and then the request will go down through the HTTP/sys kernel driver back to the connecting client. Now notice that in this scenario, I can now apply forms authentication to any incoming request, because all requests will go through the authenticate stage down here, and then they will go into one of the either native handlers or the managed handlers. So let's go through a request that comes in for an image file now. We can see that we go through the same pipeline stages, and then we pick the static file handler to execute the request, but we still had the authenticate, which ran the forms authentication module instead of just bypassing ASP.NET altogether. And then we just leave through the same pipeline stages as before. Now what this means is that I can actually apply ASP.NET type functionality to non-ASP.NET content. So I can imagine a website running on IIS written in PHP which has forms-based authentication on it, which is pretty powerful. I also can see that since there's only one integrated pipeline and only one set of stages that will be traversed by all requests, for example, in the end request stage, I will be able to determine if I need to show a custom error page or not. And that custom error page will be configurable in only one place, be it for a response coming from a native handler or a response coming from a managed handler. They will all be in the same place. So let's just look at the big points to remember on the pipeline treatment in managed pipeline or integrated pipeline. So the server provides a unified model of processing all requests, and all requests go through these self-contained stages in which I can map my own code and actually replace the code that IIS comes with by default. And then we can actually have the choice between C++ or native code and managed code if we want to feel more comfortable with .NET, or if we feel more comfortable with native code. And of course, all kinds of services that are available in the IIS pipeline will be exposed to all types of requests. And we have removed feature duplication. There's only one place where we configure authentication. There's only one place where we can configure custom error pages. We don't need to do it for IIS and for ASP.NET. And of course, we can, if I have several modules that are subscribed to the same event, so for example, in Authenticate, there are ways in which I can say which module should run first. So I have complete ordering flexibility. Okay, and obviously IIS allows me to set up either classic mode or integrated mode pipeline for each of my application pools. So now let me just go ahead and jump back into my Windows 2008 IIS 7 console and show you an application which is running in integrated mode pipeline. So in integrated mode pipeline, let me just spin up my application and go to the login page, and then log into the application. So this is an ASP.NET application, and once I log in using forms authentication, And then I can go to, for example, images, which is a list of all the images for my company. And then I can see I have a bunch of albums here with names and images. And I can go into view content, and I can just click on one of these images and get the image shown to me in larger detail down here. Now, if I click on the image properties, what you'll see is that the image is a little bit weird because there's this file resource CCON question mark p equals some number, which is not really an image if you think about it, because it is just something that you don't normally see. There's no file extension, there's no known file extension called CCON. And this is just a managed handler I have written and registered in IIS to deal with .ccon requests and go and get the image files out of a database instead of reading them from file. So if I go into my website, let me just show you how that's done, because I can go into my handler mappings here and I can see that my image handler will treat .ccon requests. And if I want to add a managed handler from my website, what I can do is I can just hit the Add Managed Handler button here, and look at this. IIS is sufficiently intelligent to actually go and look in the assemblies for my website and determine all the classes that can act as handlers. And I actually have one, which is called corporate content.handlers.filehandler. And this class implements an IHTTP handler interface, and that's how it gets recognized by IIS. Now, if I switch the pool over into classic mode, what's going to happen is, so let's just go and switch here into classic mode pipeline. The pool will automatically be recycled. So now I was authenticated since my session was in process. Going back here, I will automatically be logged out. So let me just log back in. Okay, and now you can see that the images that I used to have and were working are no longer there, because basically I don't have any filter to say please route file resource.ccon to some ISAPI extension or somewhere else. So it's just the poor static file handler that gets to treat these requests, and it actually goes looking for something called file resource CCON on disk and doesn't find it. So it says, well, it's not there, 404. So that's how the two pipeline modes differ. Now, what I also wanted to show you was that, for example, if I log out and then I do something else, I go into my website and I request a PDF file. Since PDF files are treated by the static file handler, no warning will be given to ASP.NET on what is happening. So let me just go into here and get the correct file, administration, which is called agenda iis7.pdf. And there we go. Even though I'm not authenticated, the IIS7 workshop agenda was returned to me directly by the application. Now, if I switch back into if I switch back to my application pools and I switch back into integrated mode, I will be able to apply ASP.NET Forms authentication on my content there, so that even though the static file handler will treat the request for the PDF file, I will still have to authenticate the request with Forms authentication first before actually going and handing the request over to the static file handler. So if I try the same thing all over again, now you'll see that I get redirected to the logon screen, which is the expected behavior. On a side note, please note that an optimization was done to the integrated pipeline by which modules that are written in .NET code will not be notified if the request is routed to a native handler. So in order for you to get Forms authentication working on all content, what you have to do is you have to go into the modules section and you have to say edit on the Forms authentication module, and then just uncheck this checkbox which says only invoke for requests for ASP.NET applications or managed handlers. So there you go. Now we know that there's a difference between the IIS classic mode pipeline and the integrated mode pipeline. And the last thing I'd like to show just before leaving you on this video is I'd like to route you back to my link2.me site. And there are two documents which you might find of very much interest. One of them, so if you go into the search feature and you just search for breaking changes, there are two documents that will be listed. And the first one is how to migrate an ASP.NET 2.0 application from IIS 6 to IIS 7, or from classic mode pipeline to integrated pipeline. And all the do's and don'ts. And the document is very complete because it offers all of the code that actually used to work in classic mode and won't work in integrated mode anymore, and ways to work around that. And the second document is ASP.NET 4.0 breaking changes, which actually gives you details on how to migrate an ASP.NET 2.0 application into a 4.0 application. And if you go into this magnifier here, what you can do is you can actually have a detail on the link, and if you are authenticated, you'll have a small star down here, and you can actually add this to your favorites and keep it handy. So there you go. I hope you enjoyed this video, and also please feel free to look at the first video in this series and have stay tuned for the third and final video of the IIS 7 architecture series.